Okay, this is going to be a video lesson on Trig Day 3. I want to make a new one for 2023. First question says find sine of x minus pi over 2 if cosine x equals 0.61. Okay, now here's the idea. Okay, you want to use the sum and difference from your formula sheet. Okay, from your formula sheet, find the one that says difference. Here's the formula. It says sine of A, cosine of B, minus cosine of A, sine of B. Okay, now, this is your A, this is your B. So sine of X, cosine of pi over 2, minus cosine of X, sine of pi over 2. Now, all you gotta do is do some calculations here. This would be 0. This would be 1. Okay, 0 times that would be 0, 1 times that would be that, 0 minus that would be that. Now, all you gotta do is look up at what you were given. It's saying cosine of x is 0.61, so negative 0.61. Okay, that's simple. All right, let's do a second example. Okay, it says find cosine x minus pi over 2 if cosecant of x equals negative 4. Okay? Now, I use the cosine formula for minus, which is cosine A, cosine B, plus sine A, sine B. So be careful with your formula. Make sure, just because it's subtraction, make sure you're reading. Okay? All right, took my attendance. All right? So, what we got to do with that, make sure we're level here. All right, that's better. Okay? All right, this is my A, this is my B. Okay, so cosine x, cosine pi over 2, plus sine of x, sine of pi over 2. Okay, this from the axis point would be 0. This from the axis point would be 1. 0 times cosine would be cosine times sine. All right, 1 times sine is sine, 0 plus sine is sine. Then I look up here. Now, what's the relationship with cosecant and secant? Well, it should be flipped. Okay, so that would be negative 1/4. Okay, all right. Okay, now let's move on to a couple of, you'll do some practice in class with that. Let's move on to some of the equations. Okay, so what I got here is cosine pi over 3 plus x plus cosine of pi over 3 minus x equals 1/2. Okay, so once again, use the formula. This would be cosine A, cosine B, minus sine A, sine B. Okay? All right, where this is my A, this is my B. So cosine pi over 3, cosine of x, minus sine of pi over 3, sine of x. All right? Cosine of pi over 3 would be 1/2 cosine x minus the sine of pi over 3 is square root of 3 over 2 sine of x. And that minus sign stays there. Okay? Now, this formula right here, okay, all right, I got plus, all right, is cosine A, cosine B, plus sine A, sine B. Obviously, all equaling 1/2, okay? Where this now is my A for this, and this is my B for this. Okay, so I got cosine of pi over 3, cosine of x, plus sine of pi over 3, sine of x, okay? All right, sine of cosine of pi over 3 from the triangles is 1/2 cosine. Okay, for that one would be square root of 3 over 2. Sine x equals 1/2. Now, if you notice, this and this cancel each other out. That and that combine to 1. Okay, so I got cosine x equaling 1/2. The a over h. Okay, that triangle would be pi over 3. And since it's positive, I want quad 1, quad 4. So that's pi over 3 and 11 pi over 3. Yeah, 11 pi over 3. Okay, all right. Okay, let's do another example. Okay, let's say I got cosine of pi plus x, all right, plus sine 3/2 pi plus x equaling 1. Okay. This formula is cosine A, cosine B, minus sine A, sine B. So this is my A, this this is my b. So I got cosine of pi, cosine of x, minus sine of pi, sine of x. Okay? This formula right here is plus sine A, cosine B, plus cosine A, sine B, equaling 1. Okay? Once again, this is my A, this is my B. So I got sine of 3/2 pi, cosine of x, plus cosine of 3/2 pi, sine of x, equaling 1. Okay? All right, cosine of pi is -1. Sine of pi would be 0. Sine of 3/2 is -1. Cosine is going to be 0. All right, so let's do some calculations here. That's going to be negative cosine, 0 times sine. Okay, that would be negative cosine, and that would be 0, equaling 1. Okay, now, what I got here is I got negative 2 cosine of x equaling 1, divided by negative 2. Got cosine x equaling negative 1/2, which is a over h. Okay, that triangle will be the pi over 3 triangle. But since it's negative, I want the quad 2. All right, so that's negative, I want the quad 2 relationship. So that's going to be 2 pi over 3 and 4 pi over 3. Okay, those will be the answers there. Okay, I want to do one subtraction one for you. Okay, just so you understand sort of what's going on here. Okay, now this formula here is sine A, cosine B, minus cosine A, sine B. Okay, where this is my A, this is my B. Okay, so I got sine of pi over 2, cosine of x, minus cosine of pi over 2, sine of x. Okay, well sine of pi over 2 is 1. That's 1 cosine x. That's going to be 0. Okay, so what this is going to be is cosine x minus 0. Okay, so that's that side. Now, you got to be careful with the minus. Okay, and I'm going to put this bracket here, okay, because that's important. The minus, what that's going to do is it's going to eventually change the sign of my result. Now, what I got here as a formula is cosine of A, cosine of B, minus sine A, sine B. Okay, where this is my A, this is my B. So I'm going to keep this bracket here. This is going to be cosine of pi, cosine of x, minus sine of pi, sine of x. Okay, still doing this calculation. This would be -1 times cosine of x. That'd be 0 times sine of x. All right, still keeping this bracket. That's going to be negative cosine x minus 0. Okay, so what that's going to be is negative cosine of x. So this is what I got. That's going to be cosine of x. Now, that negative, what that does is that's going to change, because of this subtraction, it's going to change that sign. So that's going to be cosine x plus cosine x equaling -2. So that's 2 cosine x equaling -2. Divided by 2, I get cosine x equals -1. Well, the only spot that's going to be at, the a over h, does not make a triangle, but the axis point of pi would give me that result. So you got to be careful with that little minus sign, okay? And you can do some practice on that in class, all right? All right, so let's go on to the last type here. All right, I got cosecant of theta minus cotangent of theta equals 1. Now, we've been talking about multiple trig functions, okay? All right, we've been talking about multiple trig functions. And so what we want to do, okay, is the first thing we want to do is try to take a GCF, okay? If we can't take a GCF, we look for a formula or identity. The problem is with this is there's no formula and the identities are squares. So what I want to do is I want to move this over to this side. So that's cosecant of theta, 1 plus cotangent of theta. Okay, you can move the other one if you want. Now, I want to square both sides. Now, here's what ends up happening. All right, I'm going to leave this here for right now. Cosecant squared, 1 plus cotangent theta squared. Okay? Now, what that does is if you look up at your identities, and you should have those identities, cosecant squared is equal to cotangent squared plus 1. Okay? Now I'm down to one trig function, so this gets substituted for that. Now I'm going to take out cotangent with a, so that's going to be a squared plus 1 plus a squared. Now, this I got to use FOIL or the box to do, okay, because that's 1 plus a, 1 plus a, so that's 1, 1a, 1a, a times a is a squared. So what that's going to be is that's going to be 1 plus 2a plus a squared equaling a squared plus 1. Now I'm going to try to move everything over to that side, okay? Now when I do that, that's going to be a negative a squared, and when I move that over, it's going to be a negative 1. So what I got left over is I got 2a, okay, because those combine to that. Divide by 2, I get a equals 0. I'm going to bring back cotangent. Cotangent theta equals 0. I hope we know that that would not be at a triangle. So what we have to look at is where is cosine divided by sine going to equal 0? Okay, and if I look at my axis points, okay, all right, 1 over 0 would be the first one. That would be undefined. 0 over 1 at pi over 2 would give me that. Negative 1 over 0 would be undefined. The 0 over negative 1 would give me 3 pi over 2. Okay, so that would like 0 and 1 and 0 and negative 1. That would give me 0. And those are at pi over 2. Pi over 2 and 3 pi over 2. Okay? Let's do another one. Okay? All right. I got secant squared theta plus 1 equals tangent. Well, I'm sorry. That's not right. Hold on. All right. I got secant theta plus 1 equals tan theta. Now, once again, can't take a GCF, okay? Cannot take a GCF. I don't have a clear formula, okay? So what I'm going to do is I'm going to square both sides here, okay? All right, so that's going to be secant theta plus 1 squared. This is going to be, obviously, tan squared theta. Now, if I look at my identities, tan squared is equal to secant squared theta minus 1, okay? And then I got secant theta plus 1 squared. Now, I'm going to take out secant for a. So what I got is a plus 1 squared, a squared minus 1. Okay? I would do the box for that. A plus 1, use FOIL if you need to. A squared, 1a, 1a, 1. So this is going to be a squared plus 2a plus 1 equals a squared minus 1. I'm going to move that stuff back. Okay? So when I move this back, all right, that'd be negative a squared. This would be positive 1. So if I go to combine my like terms, I got 2a plus 2. Okay, now I can do a GCF there, or I can just solve that. 2a equals negative 2. Divide by 2, I get a equals negative 1. Bring back secant. Secant of theta equaling negative 1. So that's h over a. All right. If I look at all my triangles, no situation creates that. So I have to look at my axis points, which would be 1 divided by cosine of theta equals negative 1. Well, where is that? The only place where that happens? That's going to be at pi, because cosine is at negative 1. Okay? All right, and now you can practice one of those in your notes. Okay? Now, the big thing, all right, the last thing I want to talk about, if you ever come across you're solving an equation, okay, and you do all this work, okay, all this work, and you end up with one of these three things. Cosine x equaling sine x, negative cosine x equaling sine x, or cosine x equaling negative sine x. Some people will think, Mr. Evans, I can't get an answer with that. But if you look at your triangles, if you remember this triangle, which is the pi over 4, we got 2, square root of 2, square root of 2, where this is h, o, and a. Okay? Now, if you remember, if you take cosine, cosine is square root of 2 over 2. Sine is square root of 2 over 2. So there's some similarities here. Okay? So this, what this means is same ratio, same sign. Okay? So we know it's pi over 4 is going to be involved here. What quadrants do they have the same sign? Well, they have the same sign in quadrant 1, and they also have the same sign in quadrant 3. Okay? All right, in quadrants 2 and 4, they're opposite. So what is that measurement? That would be pi over 4 and 5 pi over 4. Now, what does this mean? This means same ratio, opposite signs. Okay? So once again, this pi over 4 is involved, but what quadrants do they have opposite signs? They have opposite signs in quad 2 in quad 4. Well, what's that pi over 4 measurement? That pi over 4 measurement would be 3/4 pi and 7/4 pi. And this is the same thing as this, okay? So just as you come across that, that's what you have, okay? Now, what I like to do is to finish out this video lesson by summarizing sort of what we're doing here with solving, okay? When you're solving and you have one trig function, okay? You have a sine, you have a cosine, you have a cosine squared, but you only have one of those, okay? What you want to do, here's the process. I want to substitute a variable, okay? I want to do some algebra and solve, okay? All right? I want to resub the trig function, okay? And then I want to find the angles that work for the ratio, okay? And we've done a lot of examples of those, okay? But that's the process if you have one trig function. Now, if you have multiple trig functions, okay, this is what you should try to do in order, okay? So you have different ones. First thing you should try, okay, see if you can do a GCF, okay? See if you can move everything to one side and do a GCF. If that solves it for you, great. You don't need to do anymore. Or see if you can substitute a formula or an identity, okay? Obviously, if one of those double angle formulas work, put those in there. If that doesn't work, put an identity in there, okay? All right? Or what you're going to have to do is square both sides, all right, to make an identity. Okay? All right? So you got to do one of the, and this is the order I would do them in. GCF first, easiest. Sub a formula, identity, easiest. Square both sides. Don't start just jumping into things, okay? Now, once you've done that, all of these, then you want to repeat the process for the one trig function, okay? So as you go through your formative and as you go through your summative, make sure that you are following this process because this will help you be successful.